Hi, I'm Greg Richtenburg. I'm here at Tektronix in Beaverton, Oregon, and today I'd like to talk to you about our 400G-ZR Coherent Optical Modulation Analyzer. So we had a couple goals when we put together the system. First, we wanted to produce a 64 gigabaud, 16 QAM signal from the ITRA transceiver. Now, ITRA stands for Integrated Tunable Transmit and Receive Optical Assembly. So the ITRA is typical of a transceiver that will be used for metro, data center, and even long-haul communications in the future. And this ITRA has been supplied to us by 26 Optics, formerly known as Finisar. And the other thing I wanted to point out when we built the system, the receiver here, this is our OMA, and the receiver is the IQ receiver from Coherent Solutions. Now, Coherent Solutions and Tektronix have entered into an exclusive agreement to build fully integrated optical test systems. So let's talk a little bit about the signal flow. First, we used Source Express, which is a software package that we use with our AWG to produce our coherent electrical signal. So we also use Source Express to pre-compensate for losses in these electrical cables. So the in-phase and quadrature signals now are sent into our I, XI, and XQ input for the I2 transceiver. Now the Y inputs, those are terminated because for this experiment, we're only doing one polarization. Now the ITRA transceiver has internally its own C-band laser and EDFA. So that C-band laser then is modulated by these electronic signals coming in from the AWG. And now we have our coherent 64 gigabaud, 16 QAM signal. That's further amplified by another EDFA and comes into the IQ receiver signal input. So the IQ receiver is a 70 gigahertz receiver, which operates on both C and L band. It has an internal C-band laser also, which is used as our local oscillator. So now that LO and our other source signal now are down converted by the receiver to baseband, and we have our I and our Q signals, which are digitized by two ATI 70 gigahertz oscilloscopes. Okay, so then those records then are served up to our OMA software, which is running on an external PC. Now the OMA software then is responsible for all the signal processing and the phase and the clock recovery. Our 16 QAM constellation, our I and our Q I diagrams, bit error rate. We can also see the optical spectrum and our input bandpass filter. On another tab, you would see our measurements and statistics, such as phase angle, skew, EBM, and other measurements that are required for 400G-ZR. This has been a technology demonstration of our 400G-ZR optical modulation analyzer from Tektronix and Coherent Solutions. If you do like more information, please check out tek.com.